Hi, everyone. It looks like it is about 10 o'clock on the dot here, so we can get started. My name is Madeline Landis, and I am an equipment sales engineer at Long. Today, presenting on my behalf is Daniel Evans from CRC. He's going to talk about their valve offering as well as just kind of some key differences that they might have and just introduce you to their product here today. So I will let you share your screen, Daniel, and we will get started.
All right, all right. So we'll jump in. Yeah, I'm gonna spend some time talking through some of our valves and monitors. I know we have a short time here together this morning, but we'll jump kind of right into it, and we'll look at a division here at CRC we call our control ventilation. I'll run you guys through some of what those products look like, and then some of our monitors, and kind of round it out towards the end. So when we get into our control ventilation, what it is, it's prefaced with our air valve. And so the air valve technology that we use is known as closed loop venturi. It's our patented COV technology. And what that does is it allows a real unique way for us to be able to measure airflow. And we do it by means of, oh, bear with me. Did not mean to advance that. By means of ability to take full measurement and then control with it. But one of the things we do is we reduce a lot of valve free area or obstructions that are in the airstream. And it gives us things like high commissioned accuracy, ability to have flexible installations for inlet or outlet conditions. One of the things we do with our damper design is know that in critical environments we have a large could be a turn down or swing of applications from what we're running, have an ability to support a large set of airflow. So as part of that, using this technology, we implemented it into a lot of our products. A lot of the products that are available. Apologize, guys. I am having a bunch of issues with my computer. So one of the products we're going to talk about is what we call our fume hoods. So when we bring this product available to our fume hoods, what we do is we can bring the technology we have with our air valves from a ability to measure and control, but now it pairs with the other things that we need for like a fume hood application. So as part of this, we talk about the safety and monitoring of the space, the validation of the space, the rapid response. And one of the areas we see there are applications like our variable volume, our constant volume, our valve safety cabinets, floor mounted, dual side. But when we do these, one of the things that happens really well is that ability to measure flow with that COV technology paired with our fume hood controllers. One of the other items that we have inside this group is called our integrated room solution. Now what we're starting to talk about are the things that we have to do inside of these spaces. So one of the areas that's there with regards to these spaces is what items are we need to do from a validation of flow, airflow measurement. And what happens is you bring all these parts and pieces together and we start getting things like non-proprietary room level controllers, some scalability, an ability to have environmental monitoring tied in, which we're going to talk a little bit on today as well, and get some of these alarms and systems together as one of the areas to really help develop and implement these critical environments. So we're looking for things in healthcare, laboratories, manufacturing facilities, clean rooms, all these areas that we have these critical spaces that are going to be a little bit different than our normal spaces that we design and develop and have a different standard operating procedure, different codes and standards. So one of the things that we do is I want to talk about dead-ended technology. So when we implement anything here at CRC, we use a technology known as dead-ended. So the biggest thing there when we talk about flow measurement, whether it's in our air valves or our airflow stations or even doing room pressure, what we use is we use a device that will sit between whether it's in our air valves between the inlet and throat section or with regards to our airflow stations, across our airfoil or in room pressure from room to room. So what we have up here is kind of some implementations or directions that happen for how the sensor works. So on the left side, what you guys can see, that would be an extreme zoomed in view of what the sensor does. So it's a diaphragm based sensor. And as part of that diaphragm-based sensor, what you see that yellow cutaway in there is a physical separation from, a sensing side and a reference side. So as air is sensed, it doesn't pass across the sensor. What it does is it interacts with that diaphragm in the center, and based on the deflection of that diaphragm, we can derive whether it's flow or room pressure. So if you look at it from like a pressure sensor side, we'll have a sensing port or a pickup, and we've all seen those in ceilings or walls inside the space. But as part of that, one of the things that ends up happening there is there's no air that passes in. There's no flow through that will happen. So one of the big things you get there is you get really good long-term stability. As part of the long-term stability, we can also reduce the maintenance required or any kind of filtration. And the reason being there is all the contaminant and dust and dirt that exists inside of our space, we don't see picked up and then carried into these environments that would be part of healthcare or labs, most often seen on our return side or on our exhaust side. So when we look at this dead end technology, so we use it for all of our products available in the CRC portfolio. And how it works or how we manage for it is, I apologize again. So we have a couple different areas that we're going to bring this technology in. It allows us to maintain the repeatability and the accuracy that we talked about, and that is regarding our monitor environment. So we use this in our monitor environment, so we have the ability to stay away from any of that contamination or fouling. We get into our control ventilation. I talked about using our air valve. So there's a cutaway of our air valve and kind of how our air valve works. So instead of having anything inside the airstream, what we'll do is we'll use sensing ports both at the inlet where you see the darker blue shaded arrows and at the throat section, the lighter blue shaded arrows. And putting that flow sensor across those two sections allows us to drive flow without the passing of flow from one to the other, limiting the risk of contamination. And then again, we bring that technology into our measure airflow solutions, which we employ another passive indirect device like our airfoil, where as air passes over our airfoil, we do the same thing. We can take a differential between what would be the light blue and the dark blue going over and under the airfoil and bring that back to that dead-ended sensor that then will restrict it from any kind of airborne contaminant or any kind of issues that may help the sensor accuracy or repeatability of the system. So now we talk about monitoring with it, and what do we get with monitoring? So this is a real thing that we're seeing come up a lot inside of spaces, and I want to take the time to just kind of highlight some of the areas. So one of the things that we see when we think like monitoring and research in lab space is it's a lot of ability to get to some kind of precision, protection, maintain integrity of the space. So we think about things like research's outcome, personnel safety for anybody doing BSL style containment spaces, certified spaces, whether it's through the CDC, the FDA. And what we want to do is ensure that we have the ability that we can both maintain the space, but also display it locally for the users of the space. Same when we talk about it inside healthcare, right? So now inside of healthcare, a big thing we do is we want to increase the awareness of what's happening inside these spaces and what can we do from a monitoring and control side longevity so that we can prevent the infection spread or ensure that there's occupancy and safety inside the space, regulatory compliance, all the things that are required for us to maintain these spaces. When we look at monitoring codes and standards, I want to throw a couple out there because it's becoming a big one that is available inside our not inside, but we see it a lot inside of healthcare, right? So monitoring inside of healthcare is a really big function we're seeing. So we have a standard out there, ASHRAE 170, which is our ventilation of healthcare facilities. And inside that, we have a bunch of tables that tell us a bunch of information about what we need to do from a design standpoint in the space and implementation standpoint inside the space. So we have tables 7.1, 8.1, 8.2, 9.1, and each one has their own requirements, right? You know, table 7.1, obviously inpatient. We're going to be talking our towers and our items regarding isolation rooms and operating rooms and compounding pharmacies, endo labs. We get an 8.1 and we see a lot of the similar spaces, but these aren't going to be ones that need any kind of overnight stays. But the big thing as part of that, we look at ASHRAE 170. One of the real optics that we have there is the number of rooms that are listed inside of all these tables, and then compare them to the amount of spaces that are requiring pressure. And I have an example that we'll look through some of these areas that exist inside the table. But as part of that, so we have the USP standards as well. So anybody with compounding pharmacy, USP 797, USP 800, have some information on here. But the big thing we want to take away is one of the big things from the environment is maintaining the ventilation controls in both of these spaces, treating them like they are in continuous use. But as part of that, we also need continuous monitoring. So one of the big things there is we want to ensure that we have the ability to monitor and we don't have a solution that's out there that may compromise integrity of the space, or over time we've lost our ability to monitor the space because of routine maintenance or schedule callbacks. So what I threw up is just a snagit from the ASHRAE 170 table 7.1, and really on here I'm going to turn on my highlighter so we can look at a couple areas. But we're very familiar when we get in here that we have like our operating rooms and our patient rooms and our corridors, our infectious isolation spaces, and we're used to seeing things like positive pressure, minimum number of air changes. We need to have pressurization, and then what do we have for our temperature and our humidity? But this kind of goes to that previous one, and I'm going to talk through a couple of the products we have available in our monitoring environment, and the area that we have there. When we start getting into some of these other spaces in the table, we see things like we need to have a clean supply room as part of our support, or a soiled workroom as part of our support. There's laundry and processing, right? And they all have this pressurization requirement that from the onset, us being able to add these and continuously monitor adds a lot of flexibility to these spaces and provides local users with what's happening. So I picked healthcare because we have a lot of things that come in healthcare, but I put up some room designs, whether it's a pharmacy, a surgical suite, or a patient room. And what you can see is all these have a very similar characteristic, right? We're going to have some kind of air valves for our ventilation of space, capture devices as part of them. But if you look at like a pharmacy and a patient room, we see a lot of rooms that are interacting close adjacent to each other. And what happens there is we want to ensure that we have the right information available for the local users, along with the ability to maintain these spaces. So as part of it, what we look to do is say, okay, how do we put information available to users that are out there? So one of the products I have up on the screen is our alpha room pressure indicator that we see employed into a lot of spaces. And one of the reasons why this is employed into a lot of spaces, it gives us that ability to validate local space, support the users that are inside the space, gives us a real nice ability to put in that high accuracy. So we have the ability to measure pressure. We do it in that patented technology that we have with regards to the dead-ended sensing technology, not passing any kind of contaminant from one space to the other, reducing the requirements for some of that um, scheduled maintenance or cleaning of sensors. So it works really good in a lot of these areas, and I was talking about that in healthcare, right? We have a lot of these support areas that we're seeing more and more implementation of the ability to validate flow, and this is one um, works really well in a lot of these spaces that we have. Oh, I think did my screen just disappear on you, man? I apologize.
We just lost you.
All right. Yep. Apologize. I am in a wrong conference room. All right. I think it's back. Again, apologies. So we're talking about the alpha. We're talking about the implementation of the alpha inside these spaces, and what it does for specifying and laying out or having the ability to present pressure. And one of the real nice things about a product like this, it's a really simplified product, right? So when we go to install this inside of a space, one of the great things that we have is, the ability just to rough in a single gang box, have a product that shows up, get it installed so that a lot of these ancillary spaces that before maybe in joint commission or validation, we've been struggling to recognize that they've been maintaining or only doing that annual the annual validation, we can do more continuous validation inside the space. Moving into a product like our integrated room pressure monitor. So our integrated room pressure monitor, similar to what we have inside these products, is one that's designed now as an ability that we can start talking about more information, right? So when we look at these spaces, the biggest things is we want to ensure that everything is operating as it should throughout the entire use of the space. And one of the areas there that we have is how do we maybe bring more information available? So inside this series, it works with our air valves as part of our integrated room suite. It has a high accuracy, great sensing capabilities. But one of the things that this does is we bring things like adaptive modes in, integration into building automation networks. And one of the functions and reasons why we do that is, again, have the information available. Using these modes, we can do things like occupied and unoccupied, and focus on spots inside of a space that we may not have had much implementation or interaction previously. Applications we look at, our occupied spaces, our infectious isolation, our operating rooms, our research labs that we talked about before, right? Like one of the big areas to make sure that we have our research labs that are maintaining from a personnel and an outcome. Compounding pharmacies, get into spaces like manufacturing and clean room, right? Where we have a need and a jettison to have things stay repeatable, scalable, reliable, and how do we have this information that we can present in a way that the local users use it, and we're not compromising the outcome of the space, so that we don't have callbacks, we don't have commissioning errors, we don't have issues trying to get into a space that's part of that critical zone that we're looking to maintain. So I know these are our short coffee breaks. So I wanted a chance to kind of really talk through a couple of items with you guys. We have the prizes up here from Long, but the biggest thing going through is our product portfolio as we look at it and the things that we do. Going to the earlier where we talked about that dead-ended technology. That's really one that reach out to us, reach out to Long. We love talking about it. It's really a cornerstone of what makes our products um, so strong in these spaces from an accuracy and a stability and a reliability standpoint is staying away from what we would typically call, routine maintenance or some kind of interaction, right? Whether it's got to be to go clean the device, recalibrate or rescale, those are all things that have high impact to the outcome of these spaces. And then, we use that in our air valves to manage the flow rate so we can do things like maintain that fume hood containment, the room level for interaction, and then subsequently get into being able to measure and validate the spaces. One of the big things we see in a lot of implementation and standards that are coming for these environments is really how do we validate the space and ensure that it is doing as it is, but also give that ability to the local users of the space. Could be anywhere from the healthcare surgeon, nurse, technician, to a researcher, a student, or a professor.
Well, thank you so, so much, Daniel. We really appreciate your time. And I mean, for me personally, that was really, really super beneficial. So I appreciate it. And with that, I will announce the winner. You can either get $100 Benihana gift card, a bacon soda, or a coffee mug. So if you just want to get with your Long salesperson, you can also contact me and we will make sure that you get your prize. Hope that everyone has a fantastic Thursday, and we'll talk to you soon.